Station, this is Houston. Are you ready for the event?
We are ready for the event.
House Committee on Science, Space, and Technology. This is Mission Control, Houston. Please call station for a voice check.
Station, this is Science, Space, and Technology Committee Chairman Lamar Smith. How do you read me?
We read you loud and clear, sir, and welcome aboard your space station.
Captain Kelly and Dr. Lindgren, thank you very, very much for spending 20 minutes with us today. We have a number of members of Congress right here eager to ask you questions, and we're going to keep our questions short to try to get as many in as possible, and I'll start off. I had a number of questions submitted by schools and students back home in my congressional district in Texas. I selected one from the Winston School in San Antonio, and that question, just to be directed to both of you, is what should students study if they want to work for NASA or become an astronaut?
Well, sir, NASA is a pretty large organization, and there's there's all different fields that our employees have backgrounds in. But I think with specifically you're talking about like engineering and science, and as an astronaut you have to have a background in those kind of fields, some type of technical degree. There's a lot of confusion. A lot of times people think most of the astronauts come from the military, and that's not true. We have probably an equal mix in our office of civilian and military personnel, but I think one thing they have in common is really good performance in their chosen technical field, and then a really diverse varied background of the other things that they do that's not part of their professional life. And what I tell kids is, they should pick something that they like and something they're interested in, because they're better or more likely to do well at it.
And I would, sir, I'd just add to what Scott said, that when I talk to kids that want to pursue a career in space flight, and specifically to get to come up here and explore with us, that they need to really focus on the science and math and those sorts of things, because that is the language of space flight, and
Okay.
and they need to be fluent.
Thank you very much. The ranking member is recognized.
Thank you very much. Dr. Lindgren, as a former nurse, I'm thrilled to see a former emergency medicine practitioner above the station. And is NASA leveraging your expertise in medicine and physiology to reduce the risk for long-term space travel? And Commander Kelly, thank you as well for being there.
Thank you for that question, ma'am, and thank you for your service as a nurse. I think that NASA, when we are selected, we definitely take individuals from a variety of career fields, and so I feel very fortunate to represent the biomedical and healthcare professions in the astronaut office. And I think that we certainly, I certainly utilize my background in terms of teamwork and good communication, being able to work under difficult conditions. All of that training has benefited me up here. Speaking specifically to the biomedical research and identifying areas and experiments where we can help folks on the ground. We have a whole suite of experiments up here, 240 experiments during the time that I'm here, and I think Scott will have seen 400 different research projects during his year up here. And many of those are biomedical in nature, looking at bone loss, muscle wasting, immune system dysfunction. And we have a project that was up here that Scott got to work on with mice, a rodent research. Us identify areas where we can bring results from up here to benefit folks back on the ground.
Thank you. The gentleman from Illinois, Mr. Hultman.
Thank you, Chairman. Thank you both for your service. We are so grateful Captain Kelly, Dr. Lindgren. Great to have you with us in our committee today. I talked to my local expert, my 11-year-old son, Cole, to ask him a question he would want to ask you. One question was, if you know what continent you're over right now, or how fast you circumvent the globe, and then also what experiment or project you're most excited about that you're working on right now.
So right now we're over the southern part of South America, and we're heading across the Atlantic and soon to be over southern Africa and then up into Europe. And it takes us at 17,500 miles an hour. It takes us 90 minutes to go around the Earth one time, so we're going pretty fast. And as far as projects that I'm excited about. You know, we do so much on board here, between like the spacewalks that Kjell and I just did to robotics activities. We have a visiting vehicle coming on Sunday, should launch tomorrow, the Orbital Sciences cargo vehicle. We're excited about that. And then all the research that we do, and the research is in all kinds of different the categories, whether it's research that's focused on future exploration, or research that is focused on, you know, improving life on Earth. And, you know, both of those are in all different kinds of disciplines, whether it's medical stuff or, you know, for instance, the life support system here and how we, you know, replenish the environment of oxygen, scrub it of carbon dioxide, create water from our urine, use that water to produce oxygen, is something that's very important for exploration. And for me, you know, all that stuff is exciting in different ways. But I think, you know, the one thing that excites me the most for this particular flight is the idea of being up here for a year and expanding the envelope about, you know, how people can live and work in space for longer periods of time, because that's what it's going to take, understanding that better for us to, you know, travel further from our planet and hopefully one day go to Mars.
The gentlewoman from Maryland, Ms. Edwards.
Thank you, Commander Kelly, Dr. Lindgren. Really appreciate your service and your being here with us today. Commander Kelly, I understand that you have tried the outrageous romaine lettuce, and I wonder if you could tell us about the challenges of growing and developing a food supply and what that tells you about the things that we need to know if we're thinking about long-term extended stay and visits to Mars.
That's a tough question you ask. I mean, I'm not, you know, I don't quite understand the logistics train of going to Mars and at what point it's more efficient to grow your own food. You know, exactly the point where it's more efficient to grow your own food with the resources you need to do that versus maybe pre-positioning food there. But, you know, with the food we had on board here, it besides the nutrition and the freshness of it, there are other things that it does provide. I mean, we live in an environment here now that is just pretty much devoid of life except for us. So, you know, there's the nutritional aspect of it, but also there's the psychological aspect about having something else, you know, green up here that's living, that we can take care of, that we can see grow, and that we can, you know, utilize later as food. Right now we're growing flowers, actually, and, you know, obviously we're not going to eat those, but, you know, it's to demonstrate our ability to grow something else and also to see, you know, what effect that may have on us from a psychological standpoint. One of the things I really miss up here, besides, you know, human contact and the, you know, my friends and family on Earth, which is pretty much the number one thing I miss, is the ability to be outside and to experience nature. And I think having a, you know, ability to grow, whether it's something you're going to eat or something you're going to look at or something that's going to help replenish our, you know, our atmosphere that that we require for life, is something that's very important. And I think it does have a definite place in the future and our journey to Mars.
The gentleman from Oklahoma, Mr. Bridenstine.
Thank you, Mr. Chairman, and thank you to our astronauts. I wanted to ask a question. There's a growing concern among members on this committee about the orbital debris problem that's in low Earth orbit. And I wanted to ask a question about some of the precautionary measures. I know that the chances are remote and the probability is low, but can you share with us what your precautionary measures are and also how often they occur and if it impacts your ability to do your work on the space station?
Yes, sir. So that's a pretty complicated problem. And, you know, when you see the graphics, you see all the stuff that's flying around the Earth, the space junk. And, you know, Kjell and I just recently went outside, and you could see all the little dings on the outside of the space station. They're all over the place from stuff that's hit the station. Now, fortunately, you know, most of that stuff is small and hasn't done any significant damage, but there is damage done, and there's obviously the chance of more significant damage. There's shielding on many parts of the space station outside that will prevent, you know, some kind of catastrophic impact from small things and things in orbit. Stuff that's you know, coming from, you know, deep space is going much faster and presents even a larger problem. But there's really nothing we can do about that. Occasionally, we have to move the space station. We've probably done it since I've been up here, maybe, I don't know, maybe 5 times. You know, the U.S. Air Force can track a lot of stuff, but some stuff they can't see. Some stuff we see very late. And we had a case where, you know, I had to close all, I don't know, maybe 20 hatches on the U.S. side of the space station, and we had to go down to the Russian Soyuz and you know, the time of closest approach to pass because we didn't have time to move the space station. So there is, you know, there are things we can do to mitigate the risk with shielding, with moving the space station, with sheltering in place should we not have the time to do that. But I think, you know, space is very important. You know, technology today relies on it, and I think we really need to protect the environment that our satellites fly in, and you know, by not creating any more debris, and you know, potentially looking at ways to reduce the debris that currently exists, because that is such a critical capability for our nation and for the world.
The gentleman from Virginia, Mr. Byer.
Thank you, Mr. Chairman, and Commander and Doctor, thank you so much for your heroic service, for stretching our imagination and all of our science. We have a complicated relationship with Russia right now, difficult geopolitical situation. How is it going with your Russian colleagues? And do you share all of your data with them, and are they reciprocating with us?
Yeah, so, you know, Russia's really been a great partner for us on the space station, and that's one of the things that is great about this program. You know, besides the research value and the, you know, the exploration capability it provides, you know, the international partnership and the, you know, providing a place and and goals and, you know, a program for us to work on jointly with other nations has been really one of the, you know, the shining points of this space station, you know, relationship that we've had. As far as the cosmonauts and them specifically, you know, we rely on each other for our lives, and you know, we have to count on one another, whether it's, you know, them counting on us counting on them, our other international partners. So, you know, any difficulties that are and conflict that our countries experience is something that, you know, although we recognize that that stuff goes on and occasionally we talk about it, it doesn't affect our relationship up here because, you know, we're all professionals. We understand the reality of, you know, having to rely on one another. You know, I'll be up here with, you know, when these guys leave here next week, I'll be up here with 2 cosmonauts for, you know, 5 days. I was up here as the only, with 2 Russian guys for 6 weeks in the summer, and if there was something that was to happen to me, any kind of medical emergency, those guys would be my doctor. I mean, I have to really count on them for my life, and you know, vice versa. So, you know, we have a great relationship, and I think the international aspect of this program has really been one of the highlights of it.
The gentleman from Johnson Space Center, Mr. Babin.
This is Dr. Brian Babbitt, and you and I met, Scott, just a few weeks before you launched. We had a great visit at Johnson Space Center. I got to talk with Dr. Jeff Davis, who was doing some of the experiments and the comparisons between you and your brother Mark. And I am a dentist, and I still have a great interest in my profession, and I wanted to find out. I know your partner. I just wanted to thank him too as well, Dr. Lindgren. Lindgren, I appreciate your service. I wanted to ask you, both of you, what your oral health situation is, and also your general health from your long-term exposure to weightlessness and zero gravity. And have you had any situations where you've had a problem there, and do you have any long-term concerns about that? And again, thank you so very, very much.
Well, thank you for the question, sir. You know, the philosophy of our medical care system is really one of prevention and identifying the healthiest people possible to select into the astronaut office to maintain their health at the highest levels in preparation for flight. It's expensive to, of course, to bring a lot of tools and equipment up to the space station. So we do have a medical capability up here, both medical and dentistry capability, but it's fairly limited. And so because of our proximity to the Earth, if we really had any significant emergencies, it's always most desirable to get the affected crew member evacuated back to the Earth. Now, this is something, of course, that we're going to have to really think about as we start venturing deeper into our solar system. A trip to Mars is not going to have the luxury of a quick evacuation, and so we will have to identify a more robust medical care and dentistry care program. So I think for both of us, and really for all of us up here on the space station, we were in excellent health when we launched, and we try to maintain that level of health up here with just good preventive practices, hygiene, oral hygiene, and then also countermeasures, including exercise. And we're actually standing right next to our exercise bike. We have a treadmill and a resistance exercise machine in one of our other modules. And those are critically important to our long-term health, so that when we turn back to the Earth, that we've maintained our bone density and strength, our muscle strength, and cardiovascular fitness. And of course, those things are going to be very important for a long-duration mission as well.
I regret we only have time for one more question, quick question, and that goes to the gentleman from Colorado, Mr. Perlmutter.
Thank you. And gentlemen, thank you for your service to the nation and to the future. And my question is, and I'm very happy, Dr. Lindgren, you've got so many degrees from institutions in Colorado. My question, we heard in a panel a couple of weeks ago that the planets line up in 2033. That's the best time to get our astronauts to Mars. Do you guys think that's feasible?
Well, I think, I personally think it's feasible. You know, there's still things we need to learn, but I think we've learned a lot from this space station and our experience in space. And I think, you know, the long pole in the tent, so to speak, for going to Mars is the you know, the support of, you know, the nation, the support of our representatives in government, and of course the money. I mean, it's expensive, and we have, you know, different priorities. But I think it's a trip that is, you know, is worth the investment. I think there are, you know, there are things tangible and intangible we get from investing in space flight, and I think Mars is a, you know, a great goal for us, and I definitely think it's achievable.
Captain Kelly and Dr. Lindgren, we're out of time, but we appreciate the 20 minutes you have spent with us today. We certainly wish you well and look forward to your safe return to Earth. Thank you all again.
Thank you so much. Thank you so much for your time, and we really appreciate the opportunity to speak with you all. And we also wanted to wish Congresswoman Johnson a happy birthday.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Chairman Smith and committee members. Station, we're now resuming operational comm.
That was actually an